Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week. It's me, Kerstin Göpfrich, and this week I'm ready to go to space to answer Troy's question.
If you were to live on Jupiter for 50 years and then return to Earth, what would the time difference be back on Earth due to Jupiter's increased gravity?
Would taking a jaunt to Jupiter for 50 of our Earth years result in me being older or younger than my Earthling counterparts? Luckily, physicist Dr. Stuart Higgins is on hand to join me for a mission.
Okay, let's go to Jupiter.
Take the next left and proceed for 484 million miles.
Let's speed that up and pretend we could just teleport ourselves directly to Jupiter's gas surface. Jupiter is much bigger than the Earth. It has about 320 times the mass. It's huge. Assuming we could live on Jupiter for 50 years and, somehow survive the lack of oxygen, giant storms, and the fact there's no real solid land to stand on, then the stronger gravitational field of Jupiter's greater mass would have some peculiar effects. Crucially, compared to a clock on the Earth, a clock on Jupiter would tick more slowly. According to Einstein's theory of general relativity, time passes slower in a gravitational field. This is known as gravitational time dilation.
Being near a massive object makes time move more slowly. So on Jupiter, the big boy of our solar system, how much time would we save? On Facebook, Ike suggested 100 years. 1.2345 minutes was put forward by Martin. Stuart, please don't leave me hanging any longer.
Well, it's not much. For each second on Jupiter, your wristwatch would be running roughly 20 nanoseconds slower than a clock left back on Earth. Over 50 years, you'd end up being about 31 seconds younger compared to if you'd stayed on Earth. And yes, for general relativity fans, this is very much a simplification, not taking into account lots of other factors, but it gives us an idea of the incredibly small size of this effect.
So, a lot of effort for 31 seconds. But why do we even care about Einstein and all this time dilation?
Turns out that even though the differences are tiny, they're big enough to cause huge problems with the Global Positioning System, GPS. The constellation of GPS satellites that orbit the Earth each have their own clock on board, which broadcasts its signal to receivers, such as your smartphone. By comparing how long it's taken the signal to reach you from different satellites, the system can work out where you are. But there's a problem. The clocks in space are further away from the Earth than your receiver is. They're in a weaker gravitational field. That means, after taking into account other effects, time runs faster for the satellites. And while the differences are tiny, over a single day it can build up so that your GPS receiver is wrong by a whopping 10 kilometres.
Oh dear, I appear to be lost.
Luckily, the satellites have Einstein's equations built in, so they account for gravitational time dilation.
So a trip to Jupiter may not be the physics version of anti-wrinkle cream, but at least physics saves us the worry lines from getting lost. Thank you, Stuart, and thanks, Troy, for the question. And for next week, Matt emailed in with a question.
How can newly produced photons travel at the speed of light instantaneously without causing a force in the opposite direction? Why don't I get thrown backwards when I switch on my torch?
If you know the answer, or if you have a question for us, tweet at The Naked Scientists, get in touch on our Facebook page on the forum nakedscientists.com/forum, or email chris@thenakedscientists.com. That was Question of the Week from The Naked Scientists. Thanks for listening and bye for now.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.